Thanks for pressing play. This is Mr. Anna speaking, and we are going to now begin Unit 5. This unit is all about quadratic functions. Today's video is the first one in that series, the introduction, titled, What is a Parabola? So some questions you'll want to have answered for this video by the time you finish it, things you can look forward to for your notes. First off, what is standard form? Got a question mark there. Second off, how is a parabola shaped? I'd write these down if I were you right now. Third one, how can we graph a parabola? And the fourth one, what are the essential parts of a parabola? Things to define and call out, for example. So, before I move on, dear you, don't forget to use the pause and rewind buttons. If you missed something, you need to go back and get it. Look at it again, rewrite something, relook at something again, didn't quite get it the first time. Go back and check it again. You have that tool. It's the internet and videos. You can do that. Okay, let's move on. So the title of the unit is Quadratic Functions. And quadratic functions are of this form. Y equals ax squared plus bx plus c. A, b, and c, though, are just numbers. They're always numbers. They're some kind of coefficient, right? But you're always going to have an x squared. That's what makes it quadratic. So and a can't be 0. Because if a was 0, then it would just go away and it'd only be this. So this is what a quadratic function looks like. Y equals all this stuff here with that squared term. So here's the first example. If I have this, y equals x squared minus 5x plus 4, what that means is my a, this one here, is the one in front of x squared. Well, that's the divisible 1. So a, in this case, is 1. Look over here. Negative 5x or minus 5x, that means the b is negative 5. And c, there's a plus 4, so c is 4. Okay? So I'm going to put a little separation here. So in this quadratic function, the a term is 1, the b is negative 5, the c is 4. This term right here, the ax squared, that's the quadratic term, because quadratic implies the x squared. The bx, so this right here, that's the linear term. I'll write this down. And the c, just an old-fashioned number, that's your constant. Let's look at one more. Well, a couple more, actually. So example 2 is this one here in gray. So y equals negative 3x squared plus 2. Looking at it right away, you should be able to see that I have a negative 3 in front of x squared. So a is negative 3 in this case. However, my b term, right, that's the plus something x. This 2 here is actually my c term, because that is my constant. So actually in this equation, I have 0 just regular x's. I have negative 3x squareds, but I have 0 just x to the first powers. So here, the b term is going to be 0. So in this equation here, a is negative 3, there is no b term, and c is 2. It's very easy to confuse that and to put 2 down for b, but 2 is actually c because there's no variables next to that number. Let's look at one more of these. So we have this one right here. So y equals 5x squared plus 4x. So the a term, it should be kind of obvious that there's a 5 in front of x squared, so the a is positive 5. This time I do have this x term, just a regular x. So it's plus 4, so the b is 4. And then there's no numbers here at the end. So it's like a plus 0. So my c would then just be 0. So that's the basics of quadratic functions, just calling out what a, b, and c are. If you can do that, you can then do a lot of other stuff that we'll do later on in this unit. So let's move on for now. So when we graph a function like this, or like the other two before, these quadratic functions, they're not lines. Oops, let's go up here. So the shape of a quadratic function is something called a parabola. And if you're in Algebra 1, you've seen this before. It should be reviewed. Maybe it's been too long, who knows. But a parabola is what these functions are called when you graph them. So they're either like this, facing up, these little U-shaped arcs, or facing down. it all depends on your a term, right? That first part, the part in front of x squared. If that part is positive, then think positive, think up. It faces up. If that a part is less than 0, so negative, it faces down. And we'll see that coming up later on today and later on in the chapter. So just for now, the shapes look like this. Here's an example of one I want to show you guys. So we're still in football season, and being myself a Bears fan, I see punts a lot, pretty much 8 times a game. So the ball's punted. You know, here's the guy here. Here's Pat O'Donnell. He's punting again. So he goes to punt the ball. The shape of that path will look something like this. Right? He punts the ball, goes up in the air. It hangs up for a while. Right here, it goes about flat and then comes back down. This is a parabola. In fact, sports is probably the easiest analogy or example to give for parabolas, because any type of ball or object that's thrown or chucked or kicked, or a golf ball being hit, I mean, they always travel in this kind of path, right? This type of arc path, which is a parabola. This point here on top, so the very top of this is called the vertex. Just like geometry with your triangles, your corners are vertexes. It's not really a corner, but we kind of pretend it is. That's your vertex. And then parabolas are also symmetrical. So this line here, this imaginary line that I drew, is my axis of symmetry. That might be a comparison to art class with some things that, you know, this parabola is symmetric, so this line cuts it in half. And if you take physics, or we'll take physics, you know, you'll probably do some stuff with motion, and a lot of times with motion, you know, objects will have this type of path. You know, whether you throw something off a building or drop something or anything like that. So let's go on now to show how one is graphed. So here I have this parabola, y equals x squared minus 4, and I want to graph it. One way to graph it is using a table. So I'm going to draw my table up, x and y. I'm going to pick these values, -3, -2, -1, 0, and then 1, 2, and 3. And I just redrew the equation too, so you can see that. So I'm just going to plug them in. Well, first off, the easiest one to plug in is 0. If x is 0, well then it's going to be 0 minus 4, because 0 squared is 0, so I put -4 there. If I plug in 1, 1 squared is 1, minus 4 is -3. If I plug in 2 for x, right here, 2 squared is 4, and then minus that 4 right there, I get 0. And if I plug in 3, 3 squared is 3 times 3, it's 9, minus 4 is 5. Now plugging in negative numbers, be careful. If I plug in -1, -1 squared will actually be 1. So it's 1, because -1 times -1 is positive 1. So 1 minus 4 is -3. If I plug in -2, -2 squared is 4. Take away 4, you get 0. If I plug in -3, -3 squared is positive 9. Take away 4, you get 5. So what I can do here is just graph these points. So I'm just going to draw a really cheap sketch here. So when x is 0, y is -4. So 0, -4, that's a point, right? So 0, -4, that's a point. You can also plug in 1, -3. So over 1 down 3. You can also plug in -1, -3. I can plug in the point 2, 0. Also the point -2, 0 from these two. And then when x is 3, y is 5. And notice when x is -3, y is 5. So right now you should kind of see they're symmetrical. See how this is like my middle point, this 0, -4, and then these match, the -3s, the 0s, and the 5s. It won't always be this easy, but there's always symmetry with parabolas. We will see a pattern. So anyways, I'm just going to kind of sketch out this U-shaped arc curve as best I can, draw my arrows for continuation, because this does go on forever. And there you go. So this point here is my vertex at 0, -4. And then this axis is also my axis of symmetry in green. So that's my axis of SYM for short, axis of symmetry. And I would define that as x equals 0. Because again, vertical lines are always x equals something. So this is the green line that cuts it in half. By the way, you can also graph this with a calculator. If you want to save time and make it easier on yourself, you can do that as well. So let's say I wanted to graph this with my calculator. Well, what I could do is go to the y equals screen, so this button, and then type in, so you have the y1 equals, type in x caret 2 minus 4. This part right here means squared, right? Power of 2. And then you can press the graph button, and you'll see the graph. You can also press the second table, and you can see your entire table of values. So you can see everything, you have the table done for you. So anyways, I'm going to stop here for now. If you have any questions, please ask me in class or ask someone else. Thanks for watching, and go to the next one for today, video 2. Bye for now.